Welcome to the microengineering course. So today we start here with the basics of a microengineering. So as we know that a micro frequency range that is from a zero point 0.3 gigahertz to 300 gigahertz. That is about a micro frequency range. Now the word a microwave, if you see that micro is nothing but a small wave, is we can say that it is a small wave. If you again describe that in related relation to the wave, so, so means what we can say that small wave is nothing but a small wavelength. So at a zero point 0.3 gigahertz, if you calculate that what will be the wavelength, so that wavelength is about around a 30 centimeter to a zero point 0.3 mm. That is the wavelength. So in that particular range. So means your microwave frequency it has a small wave. So that's why that wavelength is very small. So based on this wavelength and their frequency, we have a few characteristics of a microwave engineer. Now then, if you consider that the electromagnetic spectrum, so generally we draw the electromagnetic spectrum that is about the range of the frequencies from, or we can say that a band of a frequency where your microwave frequency region is present. So now if we start here, that is about the band of a frequency. If we start with a high frequency band here, so we can say that this belongs to a high frequency band, and then we can just go ahead. This will be the VHF there, then a UHF band. Okay, and then we say that there will be the band started, that is about the L band, S band, then C band, X band, and then KU, then K, and then KA. So that is about, okay, so that is about your frequency band. And now where our micro frequency band starts, so we can say that the micro frequency band is started from this zero point 0.3 gigahertz. So if you see that, so VHF is nothing but we can say that is about a 300 megahertz. So this is about the band if start from 300 megahertz, then this will be for the, we can say that is about 1 gigahertz. So then 2 gigahertz, 4 gigahertz, likewise. So that is about the microwave frequency band. So according to that, we say here it is about to start from this zero point 0.3 gigahertz. This is about a zero point 0.3 gigahertz, and then it is about further it will be go up to the 300 gigahertz. That is about your microwave frequency band. Now this band, generally we say that a micro region that is divided into a UHF band. Okay, we can say that it is to be divided into what we can say that this particular micro frequency region or a micro frequency band is further divided into a UHF band that is called as a ultra high frequency band. Then we can say that a super high frequency band. This one is about we can say a ultra high frequency band. Then we can say that a super high frequency band. Then we say that a extremely high frequency band. So that is about your micro frequency region, or we can say that a micro frequency band is designated into that band. Now, if we see here that ultra high frequency band means we can say that a band of a frequency start from what we have. So I'll just write here in front of this. So that is about we can say a zero point 0.3 gigahertz. 2, that is about a 30 gigahertz. That is a ultra high frequency band. Then we can say that a super high frequency band, the super high frequency band start from the 3 gigahertz to, we can say that this one, sorry, this one is about 0.3 to 3 gigahertz, and then this one is about a 30 gigahertz. Okay, so 3 to 30 gigahertz. That is about, we can say, a super high frequency band. Then a 30 gigahertz to 300 gigahertz, that belongs to the extremely high, okay, extremely high frequency band. So these are about the three basic band designations for the micro region. So ultra high frequency band, super high frequency band, extremely high super high frequency band. Now if you see that this particular frequency band and their applications, so you can say that a ultra high frequency band, that is UHF, or we can say that in terms of a wave, we say that it is about the ultra short. Okay, because micro frequencies we say here it is about a small wave. In that case, a ultra high frequency, we generally say that in terms of a band designation, we talk about the wave. In that case, a ultra high frequency becomes, we can say, a ultra short frequency, ultra short wave. Ultra high frequency means what? Ultra short wave. Then a super high frequency, that we say that is super short wave. Then extremely high frequency, we can say that extremely short wave. Now, what are the applications of this particular frequency band, zero point 0.3 to 3 gigahertz? So, if you see that ultra high frequency band, that is to be used in a mobile communication. So nowadays we say that a 4G standard, or we have a Wi-Fi that is work in a micro frequency band. That is a 2.4 gigahertz, extremely reserved for the micro frequency. Say that is for the Wi-Fi, and another band Wi-Fi designated, that is about a 5 gigahertz. Two bands are there nowadays. Earlier it was only one 2.4 gigahertz, that is standard. Nowadays it is a two band they have defined for the Wi-Fi. Now here we say this band is for the mobile communication, and then a super high frequency, that is about 3 gigahertz to 30 gigahertz, that is to be useful for the satellite communication and a general purpose radar. Okay, so we can have the applications for all the band here, that we can say this will be used for the mobile communication, then this one is to be used for the satellite and a radar. And this extremely high frequency, that is a band, you can say that it is useful for the millimeter wave communication. Okay, so we can say that millimeter wave communication, or we can say that it is to be useful for the remote processing, or a remote sensing, or a radio astronomy. Okay, so we can say that this is about a radio astronomy. This is to be used, this band is to be used, that is about the extremely high frequency band, that is useful for the radio high frequency band. So that is about a micro frequency band. Now, based on this micro frequency band, we have to define some characteristics of a microwave. So what are the various characteristics of a microwave? So already we have learned this, uh, or we know that what are the frequency band there, and what will be the wavelength, everything that we know. So now we can talk about that. What are the various characteristics of this microwave frequency? Characteristics of microwave. Okay, what are the various characteristics of this a microwave? Now the range of the frequency is about a zero point 0.3 gigahertz to 300 gigahertz. So we say that a characteristics, first characteristics, we can say that it has a short wavelength. It has a short wavelength. So that is about wavelength is small because we say that a zero point 0.3 gigahertz to 300 gigahertz. That is about the frequency of the microwave band. And if you calculate that, lambda is equal to what is C by F. So C is supposed to be, we say that is about a zero point 0.3 gigahertz. Okay, into 10 to the power, sorry, that is C 3 into 10 to the power 8. And this one is about a zero point 0.3 into 10 to the power 9. So if you calculate that, the lambda, that is a, in terms of a, it will come, so it is nothing but a 1. Okay. So likewise, we will calculate that what will be the frequency, what will be the wavelength for the given particular frequency. So that is the characteristics. It has a very short wavelength, and already we say that it is a ultra short wavelength, super short wavelength, or we can say that extremely short waves. So that is called as a, that are the band or designation band by the IEEE standard. Next, we can say that it has a more bandwidth. Since the frequency it is in the gigahertz, so we can say that a bandwidth for this particular operation or in the micro frequency region is to be a large. Simple, if you say that if you are working in a kilohertz or if you are working in a megahertz and if you are working in a gigahertz, suppose it is in a kilohertz frequency, so 10 to 100K. So that is about the band. So F1 minus F 90K. If supposed to be you consider that in the megahertz, so 90 gigahertz. So that's why that bandwidth, if you consider that, it will be large. So characteristics of a micro frequency or a microwave are it has a more bandwidth or a large bandwidth of a operation there. Now next is about a small antenna size. Why antenna size is small? Because bandwidth or we can say that the wavelength is small. That's why that antenna size is small. So even if that antenna is small, so we are getting that a high gain. Okay. Even if that antenna size is small, we will get the large gain or a high gain. Along with the high gain, if that gain of that antenna is high, then naturally we'll say that that beam will be a narrow. We can say that a narrow beam antenna or this antenna work at a micro frequency is a narrow beam antenna. What do you mean by narrow beam antenna? So generally we talk about that radiation of an antenna. So if you consider the example of a dipole, this is about a dipole. Now in this dipole, we supposed to say that a radiation pattern of the dipole antenna. So likewise, this is the radiation pattern of a dipole antenna. That is about apple shape. We'll get that radiation pattern means we are getting a two lobes here. This we can say it is about a bidirectional antenna. Suppose if we say that we have the Yagi antenna that is a combination of a n elements there, so we'll get that radiation pattern that will be a unidirectional one. Now this is about a radiation pattern, a unidirectional. Okay, so that's about we say that we have the antenna, and here we have the elements and everything. So now this one is about the radiation pattern of an antenna. Now what do you mean by narrow beam antenna? Narrow beam means what? Here we say this one is about a maximum, and then we need to locate the point where we have, sorry, so these are about the points. We can say that is about a 0.707 or 3 dB point across this particular radiation pattern. So this is nothing but what we can say that is about a beam width. This is nothing but we can say it is about the beam width. Now we say that a 3 dB point, if that radiation, we say it is about a high gain, so then a radiation pattern will be looks like. So in that case, your beams will be what? It is likewise. So your beam width. Now the beam width will be narrow. So for a high gain antenna, so narrow beam will have a narrow beam there instead of that wide beam. Okay, this one is about a narrow beam. So this is about the characteristics of a microwave. So we'll get that a small antenna size. Okay, that antenna size is small, and if that's even if that antenna size is small, so we'll get a large gain, or we can say that that micro antenna will work at a high frequency and it produces the high gain, as well as it gives us the narrow beam of a operation. So this narrow beam of operation that is useful for the point to point communication, or in that particular region we can communicate easily using this narrow beam antenna. Next, we can say that another characteristics of this microwave, that is a travel by line of sight propagation, travel by line of sight propagation through ionosphere, through ionosphere. Now, means what we can say, travel by line of sight propagation through the ionosphere. So means what? So we have this propagation takes place from your ground antenna to the satellite. Suppose we have the a satellite here. Here is the satellite. Now the communication takes place from the antenna to the satellite. But here we have the region, atmospheric region, and that atmospheric region it is divided that in a different region, that is ionospheric layer, troposphere, stratosphere, and all. And if you see that ionosphere is above a thousands of a kilometer, okay, means above this, from this surface of the earth above 500 kilometer or beyond, there are the different layer. So we can say that that region is nothing but we can say it is about the ionospheric layer. It starts from 300 kilometer, but it is vary with the day and night. So we discuss later on this ionosphere layer and all. So now this in this ionospheric layer, your light is your sorry your wave is propagating through this ionospheric layer. If that frequency not in the form of a gigahertz or in the not in the range of a gigahertz, so what will happen? That ionospheric layer will absorb that micro frequency, that signal frequency or that signal, or it will be reflecting back toward the space. So now it is You can say that wave is propagating, or there is no reflection occur if your microwave frequencies are propagating. So travel by line of sight propagation through the ionosphere. Means through the ionospheric layer or through the ionospheric region, your wave is propagating. Okay, so that is about without any absorption or without any reflection. Your wave is propagating through that ionospheric layer. So that is about a characteristics of a microwave frequency signal. Another characteristics is what it will be reflecting, that is a reflection from metallic surface. Reflection from the metallic surface. So reflection from metallic surface means what? We have the dish TV at your home, that is about a parabolic dish likewise, and here somewhere that antenna is present. Okay, so you can say that this particular portion, so we are getting the signal from the satellite and dish is at the ground. Okay, so now we are getting the signal from the space, from the satellite. It will be reflecting from the metallic surface and it will be reached to the antenna here. Okay, so means that is about reflecting that micro signal from this metallic surface, that is the dish TV, dish antenna, and that will reach to the your antenna here. This one is about a LNB. Okay, here is the antenna. It will receive all the signal that will be reflected from the metallic dish, metallic structure, and here the LNB that then through this wire is connected, coaxial cable is connected, and that connection wireless connection, that wired connection goes towards your set-top box or your TV. Now this metallic object or metallic disc-like structure that will reflect your signal. So that's why we can say that your micro signal will be reflecting from the metallic surface. Okay, micro signals are reflecting from this metallic object. So that is again one more characteristics of a micro reflecting from the metallic surface. Reflection from the metallic surface. Another example or another characteristics, that is about a micro heating. So means at a micro frequencies, your food get heated. Even we can use that micro heating in a processing plant, in industry, for painting, for drying the clothes, or we can use that micro heating at a medical diagnosis or at a medical center to remove the mole, or we can say that to heal the whatever the wound is there, or through that micro radiations, so we can remove the tissue or burn the tissue. Okay, so likewise, that is about the micro radiation. So that is a micro frequency is to be used for the heating. Even you know that at a home micro oven is there. So this food has some particular dielectric constant. So at a micro frequency. Okay, so that food changes their properties. So that is nothing but the heating. So micro heating is nothing but a principle of what you can say, that is about a variation in the dielectric constant of that material. So we can say that here that micro heating is one of the characteristics of the what you can say a micro frequency. Next one, we have the molecular atomic, and nuclear, okay, resonance. So now this microwave can be used, or it has can be used at the micro frequency, or we can say that it is to be used in a purpose for a atomic research or a nuclear research or a nuclear resonance, that micro frequency is to be used. So means at a particular micro frequency resonance occur, so that is to be used in a applied research, or we can say that this device is to be micro devices to be useful for the purpose of the research. Because if you see that a microwaves are capable of interacting with a matter, and when they are interacted with the matter, so then microwave absorption takes place, and then it will provide the information about that molecular structure or a energy level of that particular atom. So that is useful for the understanding or working on this atomic or a nuclear resonance. Means what happened? So molecular resonance occur at a microwave frequencies. If we are using a certain material, so then we are able to understand that which at what microwave frequencies that resonance occur. Okay, so that is about the characteristics of a microwave. So another characteristics of a microwave is about a low power. So we know that your antenna, earlier we say that it has a small antenna with a large gain or a high gain and a narrow beam. Because of that narrow beam, we can say that your antenna can be worked for the low power operation. Okay, or we can use that microwave for the low power operation. So that is, it can be used at a low power. So these are the characteristics of a microwave frequency. Okay, so that is about a characteristics. Then we talk about that what are the advantages and disadvantages, and then we'll talk about that applications of a microwave. We start here. Advantages of microwave. What are the various advantages of a microwave? So now we have seen the characteristics of a microwave, and through that characteristics we say that it has a small antenna size, and it has a small wave, it has a large bandwidth. So that is again the advantages of a microwave. We can say that one, we can talk about that it has a wide bandwidth, because the range of the frequency, we can say that it has a wide bandwidth. Then the higher gain, already we say that higher gain antenna, or we can say that higher antenna gain. Okay, so higher gain antenna or higher antenna gain. Okay, so we can say that this way, because that antenna size is a small, so that's why that gain of an antenna is large. Okay, so why it is large? So generally, we can say that gain is inversely proportional to the wavelength. Okay, so that is about, we can say that we have the wavelength is here, so gain is here. So gain is inversely proportional to the wavelength there. So that's why if that wavelength is a small, so gain will be a small. Gain will be a larger. So because of that small length antenna, because length of the antenna is depending upon the wavelength, because of that small length antenna, it will provide a large gain there. So that's why we can say that advantages of that antenna and sorry advantage of a microwave, it has a higher gain. Less fading effect. Fading effect means what? If we say that we are propagating the signal, means we can, earlier we have seen that a line of sight propagation. So in a line of sight propagation, that wave is travel through the ionosphere. So that wave is not affected by the ionosphere. Means there is no absorption, there is no reflection, there is no variation in the signal strength. Okay, so that is nothing but the fading. So means your signal is not affected by the ionosphere, even if we are communicating a line of sight propagation. And again, we can say that there is no variation in the signal strength while we are propagating the signal through the ionospheric layer, or in any medium, your variation in the signal strength is very less. So that is nothing but it has a less fading effect. So it requirement here, that is a low power requirement. Okay, so it has a low power requirement. Why low power requirement? Earlier we say that it has a shorter wave. Okay, means we can say that lambda, we can say that it has a shorter now. Okay, means we can say that a short wave or a shorter waves we say earlier. Because of that shorter wave, we are getting that a narrow beam. Okay, even if a shorter waves are there, so we are getting the narrow beam. And because of that narrow beam there, so that all the power are concentrated there in a small area. Okay, so suppose I am saying that, for example, okay, so radiation pattern now. We just again come back to the radiation pattern. So this is about a radiation pattern of an antenna we supposed to be considered. Okay, this is about a radiation pattern of an antenna. So in a dash. So now this is about a area coverage by this antenna. If it is a narrow beam, so now this one, this is about a narrow beam. Even if again a more and more narrow there, so likewise. So means a beam width here is a narrow. Even if it is if even if it will even if it is considered that a small area of a propagation, but all the power is concentrated in that particular region. So that's why we can say that a microwave signal required a less power to be transmitted, because a signals are transmitted, it has a shorter wave of a propagation, a short waves are propagating, and that provides a narrow beam of a radiation. And because of that narrow beam of radiation, which provides a microwave signal to be concentrated in the given region. So because of that power concentrated in a small region, a small area, so the requirement of a power will be very, very small. So that's why a low power requirement. So these are the advantages of a microwave. Similarly, the advantages, there are some disadvantages. So what are the disadvantages? What are the various disadvantages of a microwave? Now there are the disadvantages while we are communicating. So disadvantage we can say that here is first is about a line of sight propagation. When we are propagating the signal, means line of sight propagations, just like we can say that in one tower, another tower, or a mobile users likewise. When we are propagating the signal from one tower to the another tower or from tower to the mobile, okay, users, multiple users. So while transmitting the signal, so maybe there may be obstacles like buildings, there may be obstacle like trees, there may be obstacles, okay, in space, okay, likewise aircraft or any other obstacles in between that line of sight propagation. So because of that particular obstacles, signals get affected. The signal strength is reduced, as well as we are get that signals are received at the end, they are reflected from that obstacle, that building or a tree or any other obstacle. So that's why that line of sight propagation is not possible if there are some obstacles in this region. Means we can say that a communication from line of sight communication means for tower to tower or tower to the user. Again, one more thing we say that when we are communicating from the tower to tower, so we need to know about that what will be the distance of the communication from one tower to the another tower. Okay, in between supposed to be there are the mountains, okay, or some obstacles are there. So in that case, what happen? That signal may lose. Okay, so means that there may be a reflection. But if you are making a tower to tower communication, since the earth surface is not a flat, since the earth surface is not flat, there is a small curvature on the earth surface. Because of that curvature, so we can transmit the signal not more than the 50 kilometer of a length because of that earth curvature. So means we say that from one antenna to the another antenna, we can transmit a signal within that 50 kilometer of a length. Is that two tower distance to be a within a 50 kilometer of a radius? Okay, so that is about because of that earth curvature. So that is nothing but a line of sight operation get affected because of that obstacle, because of that requirement of a line of sight. That is about a 50 kilometer. Then another disadvantage, your microwave signal are susceptible to the electromagnetic interference. Okay, that is about electromagnetic. What do you mean by this electromagnetic interference? So sometimes we know that at our home there are supposed to be motors, okay, that electric motors, or maybe you might have seen that a power line, power transmission line, that high voltage line, or we have a wind turbine, or we have nearby supposed to be tower or a mobile stations or anything else is there. Okay, so that get affected. That interference from these all these devices, electric motors, power transmission line, wind turbine, towers, and everything that will occur. So that will interference from those devices, and because of that, we are not able to communicate. Okay, so that is the interference, or we can say that electromagnetic interference. Even if you see that we have the radio stations or a television is there nearby, so then your signal get affected. Okay, so you just check it out how it is affected at your home. You can try to execute your operations, your micro devices, and you can work. Or if you go below the power line, so that is there will be radiation, so that is get affected. So your body get affected on it. So don't go practically. No need to go towards the where is a high voltage line is there. No need to go nearby to that high voltage line. Okay, so it is very dangerous. So that is about the electromagnetic interference. Then it is very sensitive. Your signal, or we can say that whatever the micro signals are there, that are very sensitive to bad weather. Sensitivity to bad weather. So you might have observed that because of that heavy uh, rain, at your home, that signals not reach to your dish TV. Okay, so in that case, dish TV is providing the message on the screen because of that bad weather. So we are not able to get the signal due to the heavy rain or due to bad weather. Signal strength is reduced. So likewise, message will come. If there is a heavy rain or a snowfall or a fog, okay, likewise, there are the bad weather component. So micro signals are affected because of that bad weather. And lastly, whichever the equipment we are using, all the equipment we are used at a micro frequency range, they are costly and heavy. So costliest equipment, so that are the disadvantages of a microwave, and all the we can say that we talk about the advantages along with we see the disadvantages, and that all these are related to the characteristics and everything there. Okay, so that is about a micro frequency disadvantages. Now we will see that a applications of a microwave. So now we have seen that a characteristics of a microwave, and we have seen that a advantages of a microwave signal. And from that, if you conclude here today's lecture, we can say that our frequency range is about zero point 0.3 to 300 gigahertz. And this one is a micro frequency band. It is divided into a three band, that is UHF. We can say that your band is SHF and EHF, ultra high frequency band, super high frequency band, and extremely high frequency band. So that we can say that zero point 0.3 to 3 gigahertz, then 3 to 30 gigahertz, and then 30 to 300 gigahertz. And if you compare that this particular band of your operation, that wavelength is a very very small. So that's all about it today's micro lecture. So if you have any